Okay, so let's get started. So once again, I thank you for joining for the IEEE IES Generative AI Challenge 2025 Workshop 1 for today. And then today's topic is from prototype to publication, how to write AI research paper. And our distinguished speaker for today is Professor Daswin Silva. I'll do a short introduction of the Professor Daswin De Silva, and then I'll be handing over the screen to him. Professor Daswin De Silva is a full professor of AI and Analytics and Deputy Director of the Center for Data Analytics and Cognition, and the Deputy Chair of the Research and Graduate Studies Committee Academic Board at Trobe University, Australia. He's also an adjunct professor of the Department of Computer Science, Luleå University of Technology, Sweden. His expertise is in artificial intelligence, analytics, automation, and the ethics of AI, data, and machines. With that introduction, I may now hand over the screen to Professor Daswin De Silva.
Thanks, Isaru, and thanks everyone for joining this session. It is sort of late on a Friday night, Friday evening in Australia, but I think the rest of the world is waking up, so good timing. So I'm going to share my screen. I hope everyone can see this. Yeah, just let me rearrange some windows. Okay, so this is the first or the second workshop of our generative AI hackathon, and we're looking at the importance of writing up your research, and also how we transition from an experiment or a prototype or a sample application of AI into publication. So I'm assuming most in the audience have not written a research paper recently, or maybe have written one or two research papers. So I'm going to start from ground zero itself. So why do we write a research paper? And when I say research paper, it's the same thing as an article or a manuscript, research article, research manuscript. Just the formality of the wording there, really. But it is a paper, finally. So it's about 6 to 10 pages of a novel research contribution most of the time that advances the body of knowledge, the body of universal knowledge on a certain topic. So it doesn't have to be AI. It can be in healthcare. It can be in medicine, medical sciences. It can be in physics, engineering, and so on. So just like a research paper.
Professor, your screen is black right now. Are you sharing the correct screen?
Okay.
We see a black.
All right, that's strange. Let's see. Okay, is that better?
Still, now that's fine. Now we can see a research paper.
Oh, okay.
Now okay, I think.
Can you see the slides?
Yeah.
Yeah, good. Okay. So sorry about that. I think I shared the other screen. Okay, so I'll start from the top. So research paper, article, manuscript, same thing. And something that's, especially in the AI space, something that gets read and cited even quite a lot. Besides research papers, are things like a blog post, a tutorial, a workshop, where there is, or even a GitHub page, where there is a detailed explanation of a certain algorithm, a certain application, or a certain large model. But there is a difference. There is an obvious difference between these two, where a research paper gets cited, or it can be used as part of the reference for another research paper. So what we call a digital object identifier is associated with a research paper. And if you are interested in a research career, or even if you wanted to progress a career in the industry in AI, a research paper would definitely add a lot of value to your CVs. So it's really good to publish your research as a research paper compared to writing up content for LinkedIn post or blog post and so on. So yeah, I have the why just below there. So we contribute to new knowledge, which I mentioned. So we advance knowledge one paper at a time. But then the sum of all knowledge leads to a significant development. So for example, GPT was based on many years of research into recurrent neural network algorithms. And then suddenly there was an inflection point where we had a really good, capable large model built by OpenAI, although that wasn't so much public domain. The research was public domain and open access. So that meant there can be advances in what we know about certain disciplines and fields. So the second point is that the research paper is always peer reviewed, and this adds a lot of validation. So peer review is when in experts mostly experts and other individuals in the same discipline would evaluate the quality of the research, the accuracy of the research, the validity, and the importance of the research. So basically, you would ask two questions when you start a research project: why this research and why now? And the peer review team, usually two reviewers, will ensure that the work is suitable for publication and it is actually adding or contributing to new knowledge in AI or any other discipline. Benchmarking and comparison. So especially in AI, there's a lot of benchmarking that happens because when you propose a new technique or a model, there's a few other competitor techniques or models already in research, and the rigorous nature of research makes you or pushes you towards comparison. So we all feel really good about a new algorithm that we coded or a new application that we built, but until we hit that kind of sacred point of a comparison, we don't know how good it is. And there might be 5 other algorithms that are really good. And the peer review process will expose this because other experts who have seen different variations of the same AI capability that you're presenting in your research will say that there is 5 other techniques or 6 other techniques that need to be compared against. And that also, it improves your understanding of the universe of research, but also it adds high quality, impactful, useful research into the public domain. The fourth one is reproducibility, and there is a lot of interest, especially in AI research and most sort of STEM research, that when you publish your work, you have to share the code and the data so that someone else can advance that research or even draw a comparison. And this is overall, this is really good for the health of the research ecosystem because if your results are closed, a closed experiment or closed off from others trying to reproduce these or sort of co-create the same experimental pipeline, then there'll be lots of challenges and research, the progression of research stagnates. So I go back to the best example here, which is OpenAI's GPT model was built on the transformer architecture, which was proposed by Google. So competitor organizations, Google, DeepMind, invented the transformer algorithm, but their competitor OpenAI actually commercialized or monetized the algorithm entirely. So and that's because well, at least Google believed in reproducibility, and they shared the code and the paper in the public domain, open access. So but then if you look at the sum of all effects, everyone's a lot smarter because of GPT, and if they didn't reproduce if they didn't have transformer algorithm as public domain, then the whole thing would have slowed down. Eventually, we might have had a large model that's quite effective, but it wouldn't have happened so quickly. Educational value, so lots of People read to research papers for tutorial value, to understand a new concept or understand the workings of an algorithm. Policy value, some papers are cited by government organizations or even politicians when they, or ministers and other members of parliament, when they provide draft papers for when proposing new policies or new research, or sorry, new policies or revisions to existing policies. And this is especially important in the space of AI because it's a fast evolving, very dynamic space. And if you have good policies, then we have good AI in society as well. So reputation and visibility, it obviously adds to your CV and makes you sort of popular or visible in the research domain. So Google Scholar is where we can create profiles, just like our social media profiles. We can create a profile of all our research papers, and well, you have to start somewhere. If you haven't written one, well, this hackathon is the best place to start on that journey. And then now you keep a record of all your papers and how many citations and all of that. Okay, so I think we are fairly comfortable on why we want to write a research paper. And now I move on to research approach. Just tell me if my slides become invisible or not visible. So research approach is the standard approach of, or it's a derivative of the scientific method. And I think we are all familiar with the scientific method from high school or your undergraduate days. So we start with a hypothesis or a research question. So we need to find a problem to solve. And this is something you've done already. You've submitted your one-page proposal, which has a problem description and some high-level steps towards solving this. And also, I think you've mentioned the significance of the problem. So we've gone through all of that. So we had a very large number of submissions. Thank you. Which, on the flip side, meant more work for us, but we really enjoyed reading through all the research proposals that you've submitted. So once you formulated the research question or problem, then the next obvious logical step is to find out if other people have had the same problem. So that we can learn from their contributions or their mistakes. So we conduct a literature review to find out if the same problem has been solved in different ways. And most often than not, given that the entire world, millions of researchers across the world are working in AI, most likely the same problem has been solved, maybe not in the same approach, but slightly different. There could be some version of a solution on Google Scholar or any other research database. So this is good for many reasons. Well, it's a reality check. If we think our problem is amazing, then we are dumbed down into finding out that it has been solved 20 years ago and the solution is now commercialized. It's widely available. We don't really have to do much. One good example in AI is face detection or object detection. It used to be a really hot topic, maybe 10, 15 years ago, but now it's almost perfected. So we have really good AI models for face detection or object detection, computer vision type tasks. And that the basic version of the problem is solved. Now it might be partial faces or faces wearing masks or the minimum number of features required to detect a face. It might be even the ethical implications of face detection. What happens to these faces downstream? The responsible approach to face detection. So there can be variations of this, but the baseline problem has been solved. So this is why we do a literature review. And fortunately, most research papers, the titles and abstract at least, are easily accessible. And once you read the abstract, you sort of get an understanding of whether this is a worthwhile path to progress in, or you should consider revisiting the research question or the hypothesis. And then third, you come up with research objectives. So you break down the research question into objectives that you want to achieve. So first, you collect the data. Second, you build the classification model. Fourth, you run some tests, and then maybe find a second data set and so on. That's a simplistic version of research objectives. And then you determine the best research method, which I'll talk about in the next slide. So there's different research methods, and fortunately for the hackathon, we are limited to almost two methods, experimentation and simulation, which is really good. If not, we spend maybe too much time contemplating the research methods and not so much time solving the actual problem. Scope creep happens quite a bit in research. The research design is more of a high-level sort of conceptual design diagram or even a flowchart of the steps that need to be completed in order to achieve the research objectives. I'll have a couple of examples which I will showcase towards the end of the slides. And then you build the model and you run the experiments. So building the model might be 2 lines of code off GitHub. Given the maturity of AI these days, or it might be that you have to spend a couple of weeks writing the code, cleaning up the data, and fine-tuning the parameters and so on. So it depends on the nature of the research question. Again, there is a lot of diversity in there. Thanks, Nitesh, I think, for that straight line. It's a regression line. Okay, so yeah, you run the experiments, and then once you have the experiments run, then you compare with pre-existing research. So maybe your method is faster, it's more accurate, it converges faster, it has less parameters. So you can run different evaluations depending on the research objectives. Are you proposing a faster AI algorithm? Is it more accurate? Is it more generative? Is it more creative? So you can have different benchmarks that you can evaluate against. And then you would you would try to interpret the results in terms of the problem description. So what do you want to achieve, and how close or distant are the results that you've generated from your experiments? And this is usually a discussion section in the research papers, and then I finally start writing the paper. So writing the paper doesn't have to be at the end, and I think the hackathon is a great example of this. We start writing very early on because we have some certainty that the proposed approach to solving this problem is feasible. And because it's a hackathon and we have to submit the papers by the due date, we also want to sort of speed up things. So we follow a bit of an agile approach in the hackathon for documentation, and documentation can, outside the hackathon, generally speaking, it can also be iterative and incremental. So you start with documenting each of the steps before you progress into the next step. Research generalization is when you want to evaluate. So you've tested for an industrial data set, a manufacturing data set, and you want to see if this technique can be applied for a transport application or a logistics application or agriculture example. So this is the task, the focus of generalization. So you want to make sure that your technique, your proposal, your contribution is generic enough that it can be applied across different domains for different problems. All right, so moving on to research methods, there is an entire universe of research, and starting from STEM to humanities to law to social sciences, there's so many different techniques used to conduct research. Collectively, these techniques can be grouped into 3, so qualitative, quantitative, and mixed methods. So qualitative is more social sciences, humanities, interviews, focus groups, where you talk to people and find out their impressions, their behaviors, their expectations, and so on. So that's this is your data collection, which is not highly relevant to us, but given the prevalence of AI, it might become important that we need to ask individuals how they feel about using AI for certain tasks. But for the purpose of the hackathon, we don't look at qualitative. We look at quantitative: experiments, simulations, surveys, control studies. Surveys and control studies are mostly in the medical sciences. So randomized control trials are quantitative research methods where you would recruit 2 different groups, the control and the treatment group, and then you'd administer medication or treatment type or a certain behavior change. And then after a certain period of time, you check the difference in the outcomes, the experiences. That's also something we are not doing for the hackathon. Experiments and simulations are our main focus. And mixed methods has the combination of these two. So you start with interviews, then you go into experiments, simulations, and then you come back into surveys and so on. So there's a lot of literature, or there's a lot of knowledge in the space of research methods, which is not really the scope of this presentation. So we'll leave it there for now. And then, so we are looking at experiments and simulations, but we should also be mindful of the types of AI research that's available. So 20 years ago, it was always experiments and simulations, because we're looking at building a new algorithm or applying an algorithm for a new task. So these rather oversimplified, but these are the two types of AI research we used to do. So either you build the transformer or you apply the transformer on text data or images or proteins or whatever. So that's an application. So these are still the two main categories. Build a new algorithm for classification for generative AI tasks. Apply it, or you could also do comparisons between algorithms. So you have 5 or 6 large models, and you might want to evaluate the accuracy of these for a certain type of manufacturing problem. So that's a comparison type of research. You could also do the type of research that attracts a lot of citations these days, which is the systematic review, where you look at all the literature in the past 5 to 10 years on a certain topic, and then you summarize this literature, and then you draw out certain arguments for the challenges, the opportunities, and the future, the outlook for the future of that specific area. You could also have case studies where a certain algorithm has been applied to a manufacturing use case for the past 10 years, and you want to see how effective it has been, how productive it has been. So you sort of design a case study approach around the application setting. And lastly, you can also have policy. So there can be a policy is closely related to standards as well. So a certain standard for using AI in a certain domain. For manufacturing, if you're using AI, you need to have a balanced data set. You need to have robust algorithms. You need to have fail-safes. So you can come up with a standard or a policy for using AI in a certain context. So a question to the audience, which I've partially answered. So your preferred research methods are going to be in the quant, in experiments and simulations, and mostly experiments, because we're sort of fortunate in this space. There's lots of data, and even in the IEEE has a data resource called the IEEE Data Port, which has lots and lots of data sets, real world data sets collected through projects they've conducted in the past. And because of this, we don't have to go into simulation. Simulation is when you have synthetic data, or when you're using a simulation engine to recreate or a transport scenario or a manufacturing scenario, and then you try to run the algorithm and evaluate the outcomes. All right, so bit of a brag here. There's also an AI lifecycle paper that I have co-authored a few years ago. This was before generative AI, so it's been cited a fair bit. And it's open access, so you can, I'm assuming you can see my browser. Let me know if you can't. And that's probably a good place to start developing an appreciation and understanding for the research part of AI. So this is outside the sort of mainstream content that you would read about machine learning libraries, machine learning documentation. So you might start developing an appreciation for how to write the research-focused documentation for AI projects. And this life cycle is based on many projects we've done in our research center. Admittedly, this is before generative AI, so we don't have much on generative AI here, but it's a good start, I think. Okay. So why write the research paper? I think we've cleared that part. And what sort of research methodology are we following before we start writing the paper? That's also cleared. So now we have completed writing the paper, and we need to determine where to publish. Or you can do this before writing the paper also, but where you publish matters because it increases visibility, or it provides visibility to your work. And there's a few options here: journals and conferences. There is reasonably significant difference between the two. Journals are probably for more substantial research, whereas conferences are for less substantial research. But conferences also allow you to present your work to an interested audience, and this means you will also get feedback. So maybe 20 or 30 years ago, when I was doing my PhD, the recommended approach for publishing your research is to actually do the work. So literature review, the research, all the dot points in the how to do research slide. Get your experiments and results, and then you draft up a conference paper, which is an early result or a partial result, and then you attend the conference and you present your work, and then you receive feedback from the audience, and that helps you to improve your research and then work towards the journal paper. So you start with the not so substantial research publication, the conference paper, and then you work towards a substantial research publication, which is the journal. So this is one way of describing the two, but now it's not so linear anymore, especially after COVID. Most of the conferences went online, and the feedback, the whole process was disrupted, and that meant, and also how conferences and journals are structured. So you have to travel to the conference, which is a bit of spending money, unless there is a nice society like the IES funding your travel through a travel award. You'd have to self-fund the trip, or the university has to fund your trip. So journals are still less expensive than conferences, and also because it's a substantial piece of work, so you're thinking more than 10 pages of research contribution, then it is more impactful as well. So it doesn't have to be linear, but this is sort of the old school thinking. And in some ways it still works, especially in the medical conferences. There is the value of conferences, abstracts being submitted to the medical conference, and then extended or matured, the research is matured into a journal paper. But if you start with journals where we publish, journals such as Nature and Science are top tier. So these are the best in the world. If you are publishing in Nature, any university or large organization will probably pitch to employ you as their research scientist or research lead. So Nature and Science is the top tier, and then there's maybe hundreds of thousands of other journals that formulate the body of publishing outlets for all academic research. So journal indexing is also important. So because there is hundreds of thousands of journals, we need to be sure that the journal is of high quality. So we use indexes. Indexes are similar to database indexes, or indexing in what used to be a telephone directory. It's where you find the journals grouped by a discipline. So you have artificial intelligence as a discipline, you have engineering, you'd have basic sciences, physical sciences, and so on. And there's two companies that do this indexing, so Web of Science and Scopus. So if you search on Google for Scopus journal ranking, Scopus indexing is open access, it's public domain. Web of Science is subscription only, so Scopus is the one you can see right now. If you search for Scopus journal ranking, you will find a list, and then there's filters and things, and you can scan through the list and find out a different or lists of journals for the different disciplines, and AI is also a category in those indexes. So journals are also peer-reviewed, which is further validation of the quality of the work. But outside journals, you can also publish directly without peer review if you are extremely confident your work is world-class. Top-notch research can be published as a preprint, which is on archive, and that is public domain. And besides being overconfident about the novelty of your research, it is also a good way to establish or associate the work with your name. If you think if it is a very competitive space and some other research groups are going to build the same technique or produce the same results very quickly, then you have sort of a collegial claim that I said this first on archive. So that's a secondary purpose for publishing on a preprint. And the preprint is while you get your paper accepted by a journal. So this is all out of scope for the hackathon because our focus is on publishing a conference paper. So let's get into that now. So conferences, there's more than 2,000 conferences in the IEEE, and every society, there's 25 societies and a few more councils. Every society and council has their own flagship conference and some other secondary or tertiary conferences. So in the IES, the society is sponsoring this hackathon, so providing you with the travel support to travel to Madrid for the winners of the hackathon. Our flagship conference is ICON. So the Conference for Industrial Electronics, its namesake, named after the society itself. So ICON is one of many conferences in the IEEE, but it is quite prestigious. So prestige is linked to visibility. So how many people attend this conference? And usually it's more than 1,000 people attending the ICON. There's never been an ICON with less than 1,000, and usually the number of papers submitted is between 1,000 and 2,000. So it is an accepted venue for publishing research, not just in AI, but also in things like EVs, power electronics, wireless power transfer, robotics, motion control. So lots of different technical topics that come together at this conference. Prestige is also linked to citations because ICON is a conference that is well regarded. More researchers and academics will read the papers published in the ICON versus papers published in a less prestigious conference of the IEEE. So, and this means if your paper is read, then there is a high chance of it being cited. And citations are an important indicator of the quality of your research. If 50 people read your research and find it useful and they cite your work, that means 50 other people, you have contributed to advancing knowledge for 50 other people or groups of researchers. And if that number is 10,000, for example, the transformer paper, Attention is All You Need, is probably cited more than 100,000 times. And you can find this fairly easily on, I'm assuming you know how to use Scholar. Yes, that's cited 170,000 times. And there's 73 versions of this. So this, Google DeepMind authors have contributed to many researchers advancing their careers, their research ideas and research projects. So that is significant contribution to the benefit and the advancement of research. There's also premier AI conferences that are quite competitive to get into. So that's another opportunity that you should keep in mind, keep in your radar. Maybe after ICON, you can try to build up more research outcomes, results, and then try one of the AI conferences, such as NIPS, Neural Information Processing Systems, or IJCAI, ECAI, European Conference of AI. There's quite a few that are available for the conference type publication, but you should also weigh the pros and cons of either submitting to one of these premier AI conferences or submitting to a journal, because you need journal quality research to go for the top tier AI conferences, and because they have maybe an acceptance rate of about 10% or 5%. And then sort of the philosophical conversation there is it really worth it? Because are you hyper competitive that you want to publish in the top tier AI conference? Do you think your idea has the required potential to progress to that level? And how much time and effort are you willing to invest? So it is highly competitive. AI is a highly competitive space. We see this play out in the top AI companies. Similarly, AI research is also highly competitive. So there are many factors to consider when you try to push too hard or become very ambitious about AI research and where you would want to publish your research. All right, so there's many formats of research writing, as I said, so journal articles, conference papers, your thesis or dissertation, if you're a PhD or master's by research student. There's abstracts, so there's book reviews, bibliographies, case studies. I think I've mentioned most of these, so I'll just keep going in the interest of time. All right, so now we are down towards writing the actual paper, and there's many ways papers are structured, but I'm going to be very one-dimensional here and focus on the structure of a paper for an IEEE conference proceeding or even an IEEE journal, because the IEEE has a specific focus on technology, and this structure is followed across the board, from power electronics to robotics to AI to cybersecurity. You'd find this structure is present in all the journals and conferences across the IEEE. So we start with the abstract, which is about 100 to 200 words, summarizing the entire research paper. The introduction, related work, research method, experiments, results, discussion, and conclusion. Or you might skip the discussion and bump it up into the conclusion as well. There's different ways of doing this. I'll show you some examples as well. So yeah, we probably don't have time to go into each of these details, and that's part of your mentor's contribution to the team as well, to make sure your writing is up to scratch in terms of the section that you're writing towards. And if you look at this closely, it follows the same sort of thinking of the research method, which I showed earlier. So lit review, what else is out there? This is the method I'm going to do. I'm going to build a new classifier. I'm going to build a new RAG technique for Gen AI models. And then I'm going to experiment on this data set. I'm going to get some results. I'm going to discuss the results, compare with state of the art, compare with related work, and yeah, and then wrap up the paper in terms of the contributions. So the difference between writing an email, writing an essay, writing a blog post, and writing a research paper is that it is focused writing. So we have, as I've titled, as this workshop is titled, so we already have a prototype or an idea of a prototype. So we have an experiment and some results. So we have a methodology, an AI model, an AI algorithm that we have run on some data, and we have generated some results. So we've run it across many data sets. We have the results. So we start there. Before we write, we need this. We need the prototype. But it's not just presenting the data, the experiments, and the results, which is the blog post or the LinkedIn post version of doing research. You just said you ran 3 experiments on 5 data sets using this technique. These are the results. This is the graph. This is the ROC curve, and that's it. That's what you see in a lot of Medium articles. And it should also not be a software development project where you find the libraries, you run the code, and then you have the results, and that's it. So doing research and writing it up as a research paper has to follow the methodology I mentioned earlier. So you start with a hypothesis, research question, break them into objectives, run the experiments, and very important to compare your results with state of the art or with the techniques that are accessible to you. So reproducibility is important, because if you don't have access to the results or the techniques of the other past work from those authors, then you can't really compare. But comparison is what makes research or makes our effort a research project or a research article versus just a Medium article, because a Medium article is more sort of chest beating, blowing your own trumpet. I've done this, and this is what happened. Whereas in a research paper, I've done this and it's not great. There's 50 other people who've done better, but this is my results. So you can still publish negative results, although suitability and things will vary. So research is this rigorous method. You follow the scientific method, and you tick all the boxes at each stage, and then you start writing the paper. So prototype and then to publication. So how we write this focused writing is to present a narrative that guides the reader through the research question, methodology, challenges, experiment results, as well as the implications or the future work. So someone is highly charged or excited by reading your paper and they want to do something similar. You can give some ideas or indication for what else can be done in this space based on your own experience. Don't use MNIST because it's a really bad data set for the type of problem that you try to solve. So you give these guidelines or helpful information as part of your paper, and that promotes new research. So a research paper has to, well, maybe I might say it's even essential that a research paper is targeted towards promoting further research. So you want your paper to be read, used, and cited in the next iteration. If you don't see that happening, might as well just write a Medium article, because you are presenting a case study or an example of running an algorithm on some data sets without, minus the scientific method. So that's the fundamental difference. So a balance between technical detail, clarity, accessibility. I've seen research papers that are 2 or 3 pages of equations. Not great, because you want the research communicated to a very large audience, the largest audience possible. So if you are inventing the next Gen AI model and you're only communicating this in the form of equations, then you've forced your audience to be very small, because certain mathematical equations are only read by a few people. But if you look at attention is all you need, that paper can be read by anyone. So they've really simplified the communication. So doing deep research, complicated research, and communicating that research are sort of orthogonal. They're very different things. You have to do good research, but you should also be able to build your skills in communicating this research with technical detail, have the equations, have the clarity, have the text there in the abstract introduction to show the value, the feasibility, the utility of your research, and also make it accessible with sharing the data, the code, and promoting the research to progress into the next steps. Using AI for writing is contentious, as AI is contentious already. I would not recommend using AI to write to write the original piece of work. That has to come from you, because this is sort of a creative, innovative process where you've built a prototype and now you want to communicate this to the largest possible audience, and your voice in that process, your narrative of the research is important. So don't take the shortcut and almost lose your voice in that approach by using AI to write the research paper. What is acceptable though is, if you're not a native English speaker, then you can use the AI models to sort of improve the writing. So you have some version of parts of your paper that you have written with maybe grammatical errors, or the sentences don't gel together very well. So this the funnel effect of a narrative is not so much present. Then if you've written the first version of this by yourself, an authentic first version, then it is okay to use an AI tool to improve that first version. So proofreading almost, which we do with things like Grammarly already in Word documents and the like. But do not use it to write the research. So I know GPT 4.5 and so are quite advanced, where you can upload a file of the results and ask it to write the entire paper. That is not that is firstly unethical, because of the nature of research, that it has to be a human contribution, not so much an AI contribution. And it also well, it affects your reputation. So even if an AI detection tool, even if it surpasses AI detection, human readers, human experts will, figure out that this is AI written, given certain idiosyncrasies of writing styles, and that affects your reputation then. So do not use AI for writing the original piece of work, but you can use it for things like proofreading and improving the quality of English and grammar and so on. Plagiarism is also a no-no, obviously. Research has to be authentic, a novel contribution. And we've had several cases at this conference and other conferences where content was plagiarized, and the IEEE detected these, and those papers were banned from being presented at the conference, or even if they were published, they were withdrawn afterwards. And also with plagiarism, it even if you escape all the different detection techniques, um, in the public domain, when someone reads your paper and they see the same thing appearing in another research paper, then no, in the court of public opinion, you sort of lost your game already, because people are not going to look at your research in the same sort of authentic, appreciative means as they would after you've been sort of caught out for plagiarism. So yeah, that's also a strong no. Self-citation, if you have published already, then you can cite maybe 10% or 5% of the total references of your own work. But again, the system gets gamed, and there's more and more authors citing 30%, 40% of the references from their own work. And this means they get more citations, but it doesn't really there is no benefit to research at large. So this is a challenge that needs to be overcome. So limit the self-citations to maybe 5% of the total references. So if you have 30 references, then 5% of that is maybe 2 or 3 papers which are only self-cited. Authorship and who is entitled to be an author is another consideration that publishing bodies are looking into, because there is what's called a passenger author sometimes in research papers. So this is again unethical or looked down upon. Not it's something that is not appreciated in research, because to be an author, you have to contribute to some part of the research. So we have the prototype, we have the writing, and it's sort of a large pipeline. So you have to find, brainstorm, find the idea, then collect the data, analyze the data, get some funding, investigations. So what you see as dot points on the right side, that's the whole contribution points for potential authors to be involved in authorship. And what you should do is also read this credit statement, which is an ANSI NISO standard for who is an author. And that will help you to sort of make sure that everyone who's named as authors in the paper are actual contributors. And here I would like to mention the mentors that are supporting your research groups are supporting the research itself. So they are entitled to be authors. And they will contribute across these dot points to make sure your research is of value and well communicated in the research paper. So the mentors will contribute as authors, and especially things like proofreading or reviewing and editing. The mentor's role is one of authorship and mentoring, because they will make sure that your research is suitable for publication in an IEEE, in a prestigious IEEE conference. Okay, so on that note, I will open up for questions. But just to get a hang of the papers, slightly out of self-interest as well, co-authored these papers. I'll show you a couple of other papers that our group have published. So this is recent, and it's largely in Gen AI. And this was in 2023, I believe, sort of in Gen AI was new. So we're looking at chatbots at that stage. So we have the abstract, summarizing all the research, and then we have an introduction. So we're looking at GPT-3, that's how old the paper is. Some backgrounds. So an IEEE conference paper will have an introduction, which is slightly longer, maybe 2 columns. And we try to bring some of the literature review into this as well. So related work, lit review becomes part of the introduction. And then the second section is the technique or the methodology. So in this case, we have a high-level diagram that breaks down the technique, and then we go into details of the different segments of this diagram. So quite often, if you pair your writing with a diagram, then it is a lot easier for the reader to follow, because they can look at the diagram to get the big picture, literally, and then follow through with the arrows and connection points, follow through with reading the text. Without a diagram, if you can also do this with equations, but if the equations are sort of widely recognized and understood, then it's much better to have equation, and diagrams are also really good to have. So figure 2 breaks this down further. So we're looking at conversational AI. So we have this as an example, and then some tables as well. And then section 3 is all experiments. So we've looked at specific scenarios because it's sort of very prototypical. And then we have the conclusion, which again can be quite short, because we have to make sure it's 6 pages, because the conference will only accept 6 pages long papers, and that's including references as well. So I'll quickly show you another paper, which is from a journal, and this is 10 pages. Again, so in this case, because we have some breathing space, we have a separate related work section. In this case, the introduction is also fairly long. So one other thing to note in the introduction is that you have to identify your research contribution. So what is the purpose of this paper has to be clearly articulated. And this is a reflection of your research question and research objectives. And if I go back to the previous paper, we probably have this as well. So maybe, yes, so if you have, but in this case, let's go. This is not a recommended approach, but if you break the introduction into 4 chapters, 4 paragraphs, that's sort of proper introduction, and then maybe some challenges, and then what's happening in the literature. So recent developments, that's your 3rd paragraph. And in the 4th paragraph, it's usually, that's sort of, it's almost template like. You start with in this paper and you present the contribution. Yes, so as a primary contribution, and there's probably a secondary contribution as well. And then there's also this, again, a bit of a template. So rest of the paper, the structure of the rest of the paper is also described as the last part of the introduction. And if I quickly go in here, the same structure in the journal paper. So related work is part section 2. Section 3 is the methodology. So in this case, we are proposing a new AI methodology for spatiotemporal learning in movement detection. Again, high-level diagrams broken down into low-level diagrams, some formulation, and then the experiments and the data sets. And then you can make the experiments even better by having some instances presented. So in this case, images, a lot more easier to understand than looking at tables. Very quickly, I'll go into a 3rd paper. So this is also recent, also sort of self-interest. I'm a co-author here. Introduction has a combined introduction with related work. And yeah, somewhere here. Yeah, therefore in this paper, not great. We don't have, the rest of the paper is organized as such, but no, it is not a deal breaker. You can still submit this paper and it will get accepted because you have all the other essential components. Methodology, some formulations, a very large visual diagram of what's happening and where the information is flowing into, an algorithm or 2, experiments, results and analysis. Again, nice tables comparing. So comparison, evaluation with state of the art is really important, and maybe a worked example in this case. So we selected something from UN SDGs because that makes the research kind of generic, universal, and not just stuck in the technical corner of the overall context. And then conclusion. Okay, so you can pick any paper on IEEE Explore, and you'd see the same sort of structure appearing in front of your eyes, and yeah, and then you go from there. On that note, let's open up for questions, and I might stop sharing screen.
There's
Prof,
one.
we already have, yeah, there's one question in the chat.
Yep. Hi, Irene. So yeah, thanks. May have answered, yes. Yeah, many questions there. So the audience is mainly other researchers. You want your research to benefit someone else. So you would look at the same sort of technical audience. You're not writing to mainstream audience. You're not writing for the general public. As much technical information as possible. And then maybe you write 10 pages and you try to summarize this into 6 pages afterwards. And then if it's still too much, then you can publish, you can have a link somewhere to a GitHub repository. And there is an appendix there for further information. PowerPoint, we'll talk about that later when we get to get closer to the conference. Okay. Any other questions? Did Michael or Mark, was it, have a question? So the other part of this is there's a lot of AI comments here. The other part of this is that it's not as exciting as writing code or experimenting with different AI models. But it's sort of the a close analogy is that this is the vegetables that gets you the nutrition. If you don't write your research as a research paper, it is unlikely to be seen by others, and that means you don't get well, visibility for your effort. You don't generate support or career advancement. It doesn't help your career. So if you're doing something in AI, it's much better to have it published rather than not published, because it adds to the knowledge, the body of knowledge, and also to sort of your research profile as well. So yeah, it's sort of the boring end of the task, but I would say it's essential to make your research more visible and useful to in the public domain. Any other questions? Virginia, a good question. Well, given that the focus should be on innovation, on novelty. So the Gen AI can be in the previous hackathon, we had Gen AI being used for data set creation, which is not so novel. But then what you did afterwards was quite interesting. And that makes the research contribution significant. So focus on innovation, and the Gen AI can be at different points of the research pipeline that you build. So sometimes it's hard to look at a lot of novelty because we don't build Gen AI models. It's a lot of effort, computing, and whatever. So that makes us consumers of pre-existing Gen AI models. But still, we can extend the Gen AI capability with things like RAG or fine tuning. So the framework is important because it gives the framework or methodology, I think what you're referring to, is important because it gives the research rigor, the research structure to how you're using Gen AI. So I go back to the distinction between writing for LinkedIn or Medium versus writing a research paper. So the framework gives the grounding for your research question. So if I think of a simple example, let's look at my research project is to look at hallucinations on GPT 4.5 versus GPT 3. Now that's sort of it has a lot of Gen AI. I'm using Gen AI, across the board, comparing to a very popular or effective Gen AI models, but in terms of research innovation, not great. So what's the point of knowing that GPT-3 hallucinates more than GPT 4.5? Not so much. We know hallucination is foundational to GPT. But instead, if you can come up with a metric for hallucinations across any model, now that there is a lot of innovation in that sort of research question. So it is very subjective, and we might be here for another couple of hours if you go into more research questions, but that's the purpose of having a conversation with your mentor as well. If your mentor has responded to your email, apologies if I haven't responded to your emails yet. So the mentor will guide you in terms of the feasibility, the innovation, the contribution of the research question. So when we have that conversation very early, we are off to a good start in terms of what the rest of the effort, the formulation of the paper is concerned. Not a direct answer to your question, but hopefully.
I think we are almost ahead of time by 5 minutes. So
Yeah.
we can take another one question and then we'll have to wrap it up.
Any thoughts from anyone who's written research papers already? Did I miss the mark completely? Huh. Thanks, Rafida. Very good.
Okay, so then we can wrap it up.
Okay, so with that, we will wrap up the session, and I would like to thank our speaker, Professor Daswin De Silva, and all of you for joining this session. And the workshop 2 of this series will be taking place on 20th March at the same time, and we will be looking into the inner workings of large language models there. Thank you, everyone, once again, and have a good night.